An RTS lives or dies by space. Imagine playing something like Age of Empire 2 and having one enemy on the entire map, or getting McFisted with thousands at a time 5 seconds after you spawn. Today I'm breaking down one of the most satisfying systems I've built for my game, the Enemy Director. This is the system that decides when to spawn enemies, which enemies to spawn, where to put them, and how to pay for all of it. But before we get to the director itself, there is a major problem that has to be solved first. Because a director that can spawn hundreds of enemies is worthless if your game engine collapses under the weight of them. So we need to talk about how I build enemies that can exist in the hundreds without killing performance. So before a single line of director logic, I had to answer a fundamental question. How do you have hundreds of enemies on screen at once without the game dying? Because here's the reality. If each enemy is a high poly mesh with its own unique material, its own texture set, its own animation graph doing its own thing, you're not fitting hundreds of those on screen. You're fitting maybe 20, if you're lucky, before your frame rate tanks. So I build a whole enemy pipeline around one goal: maximum count, minimum costs. Materials first. Instead of using a unique material, we use material instances which define all the logic. How light hits the surface, how it reads the atlas, any effects, models next. Every enemy in the game is deliberately low poly. And I want to be clear, this isn't a limitation I'm working around. It's a design decision I'm leaning into. Low poly means the GPU isn't chewing through millions of triangles per frame. It also means the art style reads well at a distance, which matters when you're looking at a swarm. You don't need to see the individual finger joints on an enemy that's at 3000 units away from the player. Now the blueprints. Rather than building each enemy from scratch, I have a single master enemy blueprint that contains all the shared logic: taking damage, dying, reacting to hits, interfacing with the director. Every specific enemy, ratchet, iron rate, whatever comes next, is a child class of that master. They inherit everything and only override what's unique to them. This means if I fix a bug in the damage system, I fix it once and for every enemy in the game. Stats are handled with data assets. Instead of hard-coding health and speed values into each blueprint, each enemy type has a data asset. Basically a structured data container that holds all its numbers: health, movement speed, damage values. The blueprint just reads from the asset on the runtime. This makes balancing so much cleaner. I'm not diving into blueprint nodes to tweak a health number. I'm changing a number in a spreadsheet-like editor and moving on. And finally, the animation. All enemies share a single master animation blueprint. It handles the state machine, like idle, walking, attacking, or dying. Each enemy feeds into the same graph. This means I'm not paying the cost of running a separate animation system per enemy. They are all evaluated through one shared pipeline. Put all of that together: atlas textures, instant materials, low poly meshes, inherited blueprints, data-driven stats, shared animation graphs, and now you have an enemy that is genuinely cheap to run. And now you can have hundreds of them. At this point, it makes sense to build a director. So the first question about the director is, why build a credit system at all? Why not just use a simple timer? Here's the thing, a timer is predictable. You get a spider every 5 seconds. Cool. But a credit system is dramatic. It can save up, it can splurge, it creates tension. Imagine you're at a low stage of the game. The director is accumulating credits quietly, biding its time. Then, boom, it has enough credits to throw a boss at you. That emergent pacing, you can't get that from a timer. The other key decision here was, where does the director get its information? I pulled the current clock stage directly from the game state. And this matters a lot. The game state is the single source of truth for the entire match. Any player, any system, any blueprint can read it and stay perfectly in sync. So when the director asks, how hard should things be right now, it's asking the same question the rest of the game is already answering. Okay, so we have a credit system. Now, how do credits actually get generated? And this is where I want to save you from a mistake I see constantly from beginners, including past me. The mistake is using event tick to add credits. Here's why that's a problem. Event tick fires every single frame. If you're running at 120 FPS, you're adding credits 120 times a second. If your friend has a worse PC and runs at 60 frames per second, they are only getting credits 60 times a second. Your game is now literally harder on a better computer. That breaks everything. The fix is that simple. Set timer by event, which is set to exactly 1 second. Doesn't matter if you're at 30 FPS or 300 FPS. Every player gets credits once per second. The economy is now frame rate independent. Now for the scaling. I multiply the current stage by a base number, let's say 20. So at stage 1, you earn 20 credits per second. At stage 5, you're earning 100. The game naturally escalates without me writing a single extra if statement. The math does the work. So now that we have credits, the director needs to spend them. And to do that, it needs to know two things: which enemy to spawn and how much does it cost. For storing enemy costs, I use a map variable. A map basically pairs a key with a value. In this case, the key is the actor class, like Wretched or Iron Wraith, and the value is the integer cost. Why not just use a big chain of if-else branches? Because that becomes a nightmare incredibly quickly. 5 enemies, manageable. 50 enemies, you are maintaining 50 branches and your blueprint looks like a plate of spaghetti. The map scales infinitely and stays clean. Now to actually pick which enemy to try spawning, I use a random integer, either 0, 1 or how many enemies there are in the current stage. But here's the thing, a map needs an actor class as its key, not a number. So I run that integer through a get node, which acts as a translator. 0 becomes the Wretched class, 1 becomes the Iron Wraith class, and so on. Now I have something the map can understand. Then I hit the find node, which is basically looking up a price tag. I hand it in the selected class, it hands me back the cost. Wretched, that's 10 credits. Iron Wraith, that's 50. Clean, readable, extensible. Now we get to the actual purchase loop. This is where everything comes together, and also where it can catastrophically break if you get the order wrong. So let me walk through this carefully. Before we spend anything, we do a branch, a simple check. Does total credits meet or exceed the cost of the enemy we want to spawn? If the answer is no, we stop. The director cannot go into debt. If yes, we get the current Doomsday clock stage to figure out which enemies can spawn. After the spend, we actually spawn the enemy at the circular position we calculated. And because every enemy inherits from the master blueprint and reads its stats from a data asset, there's 0 extra setup as spawn time. It just works. The moment an enemy is purchased, it immediately begins marching towards the center. No extra state machine wiring, no manual orders. Spawn, move, done. Drop any questions in the comments, I read all of them. Thanks for watching, and I'll see you in the next one.